Thanks everyone for coming along, and we're here to tell you about our work developing an indicator to estimate the global environmental impacts of UK consumption. I'm an ecosystem analyst here at JNCC, and I've been working on this project for the last 3 years. So to start with, I'm going to run you through the background and context for why we undertook this project, what outputs we created and where you can find them, as well as how we hope the indicator might be used. I'll then hand over to Simon, who was the brains behind much of the trade modelling and methods used to calculate the indicator, to tell you a bit about the nuts and bolts of how it works. After that, Chris, also from SEI, will run you through some of the results that we've got and give a bit of interpretation around what they mean. And finally, we'll briefly come back to me to tell you about some next steps before we go into time for questions. So the project was jointly undertaken by ourselves at JNCC and SEI York, having been funded and commissioned by DEFRA, with additional support given towards the associated dashboard by the Trade Hub and Trace. The key driver for the work was the 25-year environment plan, so the government strategy for England that sets out what we'll do to improve the environment within a generation. This includes an aim to avoid improving our domestic environment at the expense of the environment globally, highlighting that however good our domestic policies are, if we simply export our problems elsewhere, it makes little difference overall. It also has an associated indicator framework, which called for an indicator to measure against this aim. However, interest in this area is rising up policy agendas much more widely as well. Wales, Scotland and Northern Ireland have also published strategies that include wording such as sustainable international footprint and living within environmental limits. Documents such as the National Food Strategy and the Dasgupta Review also reference unsustainable consumption as a problem we need to solve. And internationally, the United Nations Sustainable Development Goals and first drafts of the Convention on Biological Diversity's post-2020 framework have highlighted this issue too. So the problem we're trying to solve is that as the UK, we consume a lot from overseas, and we don't have a very good idea of where it comes from and what it's doing to the environment there. For example, for food products, we import about half of what we consume, and that is only half part of the picture, because one of the big problems with understanding this area is that throughout the supply chain, commodities are processed into products. So whilst tracing the apple that you eat back to where it was grown might be relatively straightforward, tracing the palm oil, which is one of many ingredients within your cosmetics product, back to where that was grown, adds a whole other level of complexity. So the vision for the project was to create something that could tell us, for a range of different impact metrics, tropical deforestation, biodiversity, water stress, etc., what the UK's total impact is, including the impact from commodities embedded within more complex products, and to be able to break that down by the amount of impact taking place in each country of the world and related to each commodity that we consume. This opens up a wide range of potential use cases around identifying the commodities and countries for which action would make the most difference, including things like trade agreements and directing official development assistance. So on the 28th of October this year, we released an experimental statistic estimating the global environmental impacts of UK consumption. An experimental statistic is a statistic published officially by government, but that's still undergoing further developments and consultation. It's been a multi-year process to get to this point, starting with some work in 2019, when our contractors Route 2 completed a proof of concept study. This work was then internationally peer-reviewed, and the conclusions from that were that the approach taken in the proof of concept was the best current option to take forwards, with some tweaks to improve resolution. We then set out a roadmap for indicator development. This year, we worked with Simon and Chris at SEI, who are talking later, and who created a data set that could be used as an experimental statistic. This includes estimates for a range of different impact types, including those I listed earlier, so tropical deforestation, biodiversity loss, and scarcity-weighted water use. We also worked with stakeholders across government, NGOs, and industry to tailor it to their needs and get input on their use cases and priorities through a series of both steering group and stakeholder workshops. It was released in 2 parts. The headline results, so the aggregated totals for UK consumption across all production countries and commodities assessed, were presented as a time series for each impact metric. This was released as one of the UK biodiversity indicators, which are a set of official statistics released each year that mainly focus on biodiversity within the UK. If any of you came to James's talk 2 weeks ago, you'll already be familiar with them. It's expected that a cut-down version of these results will also feed into the 2022 reporting for the 25-year Environment Plan indicator in the spring. So this graph is for tropical deforestation associated with UK consumption. As you can see, it's decreasing throughout the time series, but remains high. For example, in 2017, we were still associated with deforestation of an area about the size of Rutland. I'll leave Chris to comment on the actual results and take you through some of the other graphs. But the key here is a high-level summary graph showing total impact. The experimental statistic page also briefly describes the methods used, the key caveats and limitations, and links you through to the technical documentation where you can download a full version of the methods and a full version of the UK consumption relevant data. Results are also presented separately on an interactive dashboard published at commodityfootprints.earth. This is where it's possible to break down the results by producing country and by commodity. For example, this screenshot again shows results for tropical deforestation associated with UK consumption, broken down by the countries in which the impacts are taking place. And again, I'll leave Chris to talk about the results later and instead focus on the what for now. So the results cover every production country for which there's underlying data. You're also able to select a commodity that you're interested in to view the breakdown of impacts by commodity. All metrics include all crop commodities as recorded by the Food and Agriculture Organization of the United Nations, and some metrics also include cattle and timber. From a consumption country perspective, there's also more data than just the UK. You can select one of 44 other countries, with other countries grouped into 5 rest of world regions, for example, rest of world Africa, rest of world Asia, etc. It's also possible to change perspective and view the data from a production country's perspective to estimate where commodities produced in that country and their associated impacts are eventually consumed. We're hoping that the indicator will be useful in lots of different ways for lots of different people. It was released as one of the UK biodiversity indicators, as I mentioned, and is planned that it will feed into the 2022 reporting for the 25-year Environment Plan. DEFRA have also put it forward as a proposal to the Convention on Biological Diversity for consideration as an international indicator there. You can view their submission on the CBD website. But probably where the indicator can be most useful is its ability to estimate impacts specific to commodities and countries. This opens up a wide range of potential use cases, including providing evidence to the environmental chapters of trade agreements. The EU uses a similar method as part of their process for this, and supporting multilateral environmental agreements. Knowing which commodities are associated with the highest impacts also provides evidence for more targeted actions. For example, it will be a really useful tool for identifying which commodities should come under scope for supply chain legislation. We also think it could have potential applications in, for example, directing overseas development assistance spend. It could be argued that if we as the UK are associated with lots of impact in a particular country, there's a greater need for or justification of spending ODA there, particularly ODA aimed at improving sustainable production practices. It could also be useful in aligning industry actions and highlighting displacement effects from domestic land use decisions. For example, if we decide to restore forest area here, is that having an impact on our domestic production capacity and therefore leading to more imports having effects such as deforestation elsewhere? So what's the net effect from a global perspective? We also think it's important to recognise that the indicator itself is only the tip of the iceberg. Getting a whole economy picture of the agricultural sector at a global scale will not tell you the full story, and other metrics will be needed to fully understand the problem. Once you've used the indicator to identify a commodity or area of interest, you could then develop more detailed and specific indicators that focus in on the problem areas and are more able to measure against specific actions. 250 such tools and initiatives are explored in the Linking Environment to Trade Guide, which aims to introduce people to the subject area of sustainable production and consumption. I'll put a link to this guide, as well as to the indicator, dashboard and technical document into the meeting chat, so you can go away afterwards and explore yourselves. And with that, I will hand over to Simon, who is going to take us through some of the methods.
Hi, thank you very much for having me. So yeah, I'm going to give a very whistle-stop tour of some of the methods and focus on some of the key points that I think will be useful for understanding what we've done and, importantly, why. So I'm going to start with explaining what an MRIO is and why we use it. So an MRIO is a multi-regional input-output table, and these are basically numeric arrays, so matrices that detail the flows of money between different sectors within the economy, as well as sales to final demand. And I'll explain these terms in a bit more detail shortly. So the flows of money from between sectors, sales and purchases, represent outputs from and inputs to the different sectors. You know, if money's going one way, then a good or service is going the other. What you see on your screen is a visual representation of this. So on the left, we have an input-output table, and then on the right, a multi-regional input-output table. So an input-output table is generated to represent an individual economy. So for example, the UK produces one of these. And what you have is sales from a given sector to other sectors within the economy, and then also sales abroad in the form of exports, as well as sales to final demand. So final demand basically means purchasers taking the good or service out of the economy, so no further value is added. And final demand comprises purchases by households, as well as, for example, governments, NGOs, etc. So the rows can be seen as sales from a sector, and the columns can be thought of as purchases, or maybe more specifically where the money goes. So you have purchases from by a given sector for other sectors, as well as purchases from abroad in the form of import. And then you have some messy stuff that I don't really like talking about because it's a bit complicated, but it's basically where the rest of the money goes. So this might be in terms of wages, profits, capital investments, taxes, and so on and so forth. And what's sort of important mathematically, if not necessarily particularly interesting to other people, is that these things balance. So nothing's been created or lost. So the money is conserved, and that's important in terms of how we use these. So a multi-regional input-output table is basically a set of these national or regional level input-output tables stitched together. And the key point really here is that these purchases from sales abroad exports and purchases from abroad imports are stretched out. So rather than simply just being a single value, these sales from a sector overseas are actually then split out to sales to sectors in other economies, and likewise final demand is spread out to other countries. And similarly, purchases from abroad, i.e. imports, are split out to be purchases from different sectors across the other economies. What's worth mentioning quickly is that a multi-regional input-output table does offer a full global perspective of the economy. So in theory, everything here is captured with the exception of illegal activities such as black markets. So it gives you the full breadth of what's going on and the interdependencies. So why is that important or useful? Well, by having purchases by sectors, we can understand what the direct requirements are for a sector. So in order for a sector to be active and to produce output, we know that it's going to be dependent, and this gives us a way to actually track that. And we can go further than this if we know what a sector's direct dependencies are, and then what those upstream sectors' dependencies are, and so on and so forth. We can actually map the entire global dependencies across all sectors of the economy associated with outputs from a given sector. And then we can link this to final demand, so consumption behavior, to basically work out what the entire global activity is required, driven by purchases, for example, by the UK. So what this is doing compared to, say, traditional trade data is giving us this much bigger perspective on what's happening. Trade data typically is giving you links between sales from one country and imports in another. It's not very useful necessarily, or it's highly limited when you're looking at further downstream and actually that consumption linkage. So the MRIO gives us full breadth and depth of the economy and the activity. And this allows us to capture all sorts of consumption, as Maddie was suggesting. Direct consumption might be something like, you know, as a consumer, if you purchase an apple, you're buying very much the commodity as it was produced. But then you also have indirect trade. So for example, you purchase a loaf of bread and you're indirectly purchasing wheat, it's there as an ingredient, or further embedded. So the example Maddie gave was animal feed there. When you purchase a chicken, you're not physically buying, for example, soy, but that soy is being produced in order to be used as feed. And so ultimately you are driving that. So MRIOs are great and they're really powerful and they allow us to do things in a relatively simple way that we couldn't otherwise do, but they do have their limitations. And the main one is really one of resolution. And this is both geographic and sectoral. So these sectors, it's worth mentioning here, there are multiple multi-regional input-output tables which have pros and cons, and it's always a trade-off. But they always have some limitations. And the sectors can be quite specific, like you might have a wheat sector or a rice sector, so that's quite good for an individual commodity, but it also might be something much broader, like, for example, a fairly common one is the oilseed sector, in which case, you know, soy, palm, rape, and any other oilseeds have been grouped together. Or you might have a sector like other fruit and vegetables, which are containing a large range of commodities. So they're not very useful for getting a high resolution information, which is especially important if you're thinking about environmental impacts associated with those. And likewise, these rest of world regions can be quite large. One of the ones in Exiobase, which is the MRIO we utilised in this work, contains 60 countries. So you're highly limited there when it comes to the resolution of impacts. So what we do to try and get around this is use what we call like a hybridized approach. And what we're doing there is trying to overcome the shortcomings of traditional trade data in terms of its supply chain length, and these resolution limitations of MRIOs. So IOTA, to give it slightly unglorious full title, is really an environmentally extended physical financial hybridized MRIO framework. So IOTA is the input-output trade analysis model that underpins the data Maddie's been talking about. And this hybridization really refers to taking two different types of data and then merging them together. So we use commodity and country-specific data in physical units, i.e. mass, at the production end, and then we use these financial sectoral level MRIO tables for the consumption end of the supply chain. And what this allows us to do is to have this high resolution at the production end, which is, as I said, especially important when it comes to environmental impacts, but still retain the full supply chain coverage. And we maintain this resolution at the production end through to the consumption end. So whilst consumption is limited to being mapped at the resolution of the regions listed within the MRIO, we retain the production and impact resolution at this higher scale. And the sort of slightly cheesy sales pitch is we're basically trying to get the best of both worlds when we take this approach. So I mentioned IOTA being environmentally extended. What exactly does this mean? Well, the model and the framework as described to now, this hybridized approach, is basically giving you the flow connections between consumption activities and production in terms of the physical flows of the commodity, the quantity of this commodity that is ultimately being consumed either directly or indirectly. And what we can do is extend this by basically applying some sort of metric of risk or impact, and then we can work out the quantities of these that are embedded within these flows. And to do this simply requires some sort of intensity measure. So if you know how much is being produced and where that you are ultimately consuming, if you've got some sort of intensity for a metric of interest that you can apply to this, it allows you to calculate the risks embedded in that. The simplest one is probably land use. So if you've got a measure of the hectares per ton required in a certain country to produce a certain commodity, we can simply multiply this by the quantity that we're estimating to give you an estimate of that land use embedded in the production. And again, going back to kind of like why we've taken this hybridized approach, rather than sort of having something, an indicator simply at a sector level, potentially covering multiple different commodities, or of course geographic scale covering different countries with very different environments, this allows us to be quite specific in how we can calculate and then apply these, and then as a direct result, the level of detail in the results we can get out at the end. So along with the mass flows, and Maddie's kind of mentioned these, the indicators that we've currently got are area harvested, and which is just for crops, and that's by far the easiest one to apply. We also then have tropical deforestation and associated emissions, both including and excluding peat drainage, and that covers all commodities. We've got 3 different water footprints. So there's green and blue water use for crops, and then also a scarcity weighted blue water use. So this is the blue water footprint combined with a measure of the state of water availability in the area. And then finally, 2 different biodiversity metrics. One is species loss. So this is an estimate of the species lost being driven by the production of a specific crop to meet our demand. And then the final one is species richness weighted area, which is basically an interaction between the area being required to produce a crop and the presence of species within that area. So the work we've done is attempting to overcome some of the limitations that are by their nature quite inherent in the underlying data sets and the traditional approaches of either using a kind of physical based with production and trade or a conventional MRIO approach. But that's not to say that what we've done is the be all and end all and there's not room for improvement. Trade data by its very nature is messy. There are inconsistencies and issues with this, and within the framework we do take steps to try and work around some of this. So for example, we correct for re-exports. The UK imports a lot of soy from the Netherlands, for example, but the Netherlands doesn't produce any soy, so we know this has come from somewhere else. And we've got an algorithmic approach to reconcile that. But there's still areas where we could do more. We're currently just using the export data, and one thing we're quite keen to do is to actually incorporate import information into that to fill in some gaps and to smooth out the data. We're not explicitly modeling the movement of derived commodities, which is incredibly important for some commodities. That's not to say these things aren't being captured in the model or that their consumption is not being represented or is lost. It is. But what we can do is actually cover more of this explicitly at the production and trade end of the supply chain, and not rely on the MRIO so much to deal with that. The indicators, we've done our best and taken a logical approach to these, but that's not to say there's not room for improvement, both in terms of the actual underlying data, but also their implementation within the models. As well as improving what's already there, there's obviously scope for doing more indicators. So as well as more environmental, that might be moving towards, say, social, economic metrics, or any other thing that we want to link to these supply chain flows. The commodity coverage to date is focused on agricultural commodities, largely driven by ease of adapting the indicators to them, but we could extend that further. The MRIO resolution, we try and circumvent this as much as possible, but it's a hard problem to solve. And as I mentioned, there are other MRIOs available, and one option is to use multiple MRIOs to try and increase this and also offer a range of perspectives and values. And finally, not so much a limitation, but more just a statement of fact. IOTA is a static model, it is not dynamic. So whilst we can use this for hotspotting, it's based on historical data. And when it comes to scenario modeling or projections, it can inform that, but we need to be quite wary of what it can and can't do. So I'll end there and hand over to Chris to talk about the results.
Great, thank you. Thanks, Simon. So thanks, Simon, for that. As Simon said, we've collated a variety of different indicators into this data set, and whilst there's room for improvement, and hopefully that those improvements can be made over the course of time, I think what we have provided is really quite important for the UK in terms of understanding the overseas dependencies that we have and the environmental risks at the moment that we're exposed to in the UK, not just by those direct trade relationships, but via that full economy approach that Simon was covering. So I'm just going to talk through some of the high-level results to start with, and then move to some more granular exploration of the data that is now facilitated as well by the dashboard that Maddie mentioned earlier. Just to start with then, just drawing some things from the high level out of some of the material that was included in our indicator feature associated with the work. So this is the trend that emerges at the aggregate level. So this is across all of the consumption activity of the UK and all of the embedded crop products that are linked to that consumption. And this is the cropland area, the harvested area footprint that Simon mentioned earlier. And we can see that on the left-hand side there, the total area of cropland embedded in consumption has come down over our time series, so from 2005 to 2017, which is the time series that this data covers at the moment. As you can see on the right-hand side, however, this isn't reflected really in a change in the intensity associated with that production itself. So that's remained relatively static. The land use required for every 1,000 tonnes of production hasn't, markedly decreased. So that indicates overall that the decrease in land area associated with the UK's footprint is predominantly due to reduced material dependency overall, rather than improvements in the material efficiency or productivity overall over the whole crop portfolio that we're dependent upon. The yellow line here is the global intensity of production. So this is essentially the average number of hectares in this case used for every 1,000 tonnes of agricultural production, and we can see that mostly the UK sits below this. So we can see that our consumption overall is more efficient than, more resource efficient than the global average. Now, if we look at one of our other indicators, our indicator of tropical and subtropical deforested area, this indicator is derived from a data set published a couple of years ago now by a group at the University of Chalmers, led by Florence Pendrell, and is recognised as one of the leading data sets on tropical deforestation estimates that can be linked to crops internationally. So we've linked this up with the UK model, and we can see here that, as Maddie illustrated earlier, the overall footprint of the UK when it comes to the tropical deforested area linked to that consumption has come down relatively markedly over, again, our time series. That's not to say, obviously, there's still not work to be done, and there's obviously a lot of policy attention on this particular aspect at the moment, but it has come down from historic highs. Now, what's also striking about this is that, in contrast to our crop area footprint, there's also been a decrease in the deforestation intensity. So there seems to have been some level of decoupling that's gone on over this period between the sort of total tonnage of materials embedded in UK consumption and the deforestation extents. And again, the global average intensity is quite a lot higher than the UK's intensity. That's not really surprising, I guess, given the distance that we sit from tropical regions. So we typically associate those closer to the economies producing tropical products to have a close to average figure, because obviously, for example, we're sourcing a lot more material from the EU, which is not associated with tropical deforestation. There obviously are quite some important products as well linked to that deforestation footprint, which I'll come back to a little bit in a second. And then finally, just on the blue water indicator, the blue water indicator was derived from a combination of the water footprint network data, but we used an approach to annualize that data set so that it actually changes over time in response to crop yield effects. And we can see that, again, the total footprint has come down over our time series, and so has the intensity of blue water consumption linked to the UK footprint. So again, a rather similar picture there as for the deforestation footprint. Now, those were very high-level results presented in the indicator fiche itself, just for the aggregate consumption footprint of the UK, but those don't tell us a lot about the underlying dynamics of those trends, and obvious questions therefore emerge about what specific commodity dependencies or country dependencies might we be linked to that might be classified as higher or lower environmental risk against the more positive backdrop of those decreasing trends overall. And as Maddie mentioned, we've made basically most of the data that I'll now show you available in one form or another via our dashboard, so I'd encourage you to have a look at that. Importantly, this dashboard also, beyond just the UK data, also provides results for the other countries of consumption that are embedded within our MRIO data set. So you can actually undertake comparisons with other countries when it comes to their footprints and compare those to the UK data. But I'm going to stick with the UK data today. So using this dashboard, we can delve into more detail behind those headline figures. And this is an example again for blue water consumption. And we can see that it's actually dependency on a relatively small number of commodities that is dominating the overall blue water footprint. So this is some of our key staples like wheat, maize, rice, also some products like sugar and cotton there as a non-food product, but obviously an important agricultural commodity. We can also see, given our availability of our time series, that those have changed differently over time. So some of them have come down from a relatively more markedly over time than others that have remained more static or stable. And note here, olives appears. I'll come back to olives in a second, in a minute, but that's not a massively high volume product, but it still appears quite highly in the blue water footprint. I'll come back to that in a second. We can also break down the footprint by the source region, and this is really where it becomes important for identifying hotspots of risk. So here is a map of the UK's tropical deforestation footprint and some associated charts there on the right. And we can clearly see that it's really a couple of source countries that dominate this component of the UK footprint, so Brazil and Indonesia. And that won't come as a surprise, I don't think, to many of you, given that those really are the countries that are in the media a lot, for example, when it comes to deforestation frontiers. But it's still striking to see the level of difference that the footprints in those countries have compared to some of the other dependencies linked to the UK. And we can also see that certain commodities, again, have a much higher overall or relative footprint than others. And beef in particular here was picked up by some in response to the release of our data as receiving a relative lack of attention in some of the discourse around UK deforestation linkages in comparison perhaps to its overall footprint and the pressure that we're putting on the environment via that consumption pathway. The geographic breakdown that we provide in the dashboard also allows us to obviously look at other hotspots of concern over our other indicator sets. So again, returning to blue water here, we can see that actually, it's Central and Southern Asia regions, some parts of Africa, North America or the US specifically, and also Spain appearing here as high consumers of high users of blue water, which is the irrigated water component of agricultural production linked to the UK. But if we scale this by the blue water scarcity metric that Simon mentioned earlier, we can see actually further specificity in the actual hotspots of potential concern. So actually, Egypt is called out as a high risk, but in Europe we've got Spain here as the really the only country of concern in the European Union from a blue water scarcity perspective. And if we drill down further into the Spanish data, we can see the profile of blue water use in Spain. And this is where olives then again pop up as being one of the key water users in that region of water scarcity. So sorry, anybody who likes olives, if you're buying them from Spain, you might be causing some environmental problems via water shortages potentially. So I'm just going to finish by delving a little bit more into one specific aspect, one specific part of the data, just to show how this data can be unpicked a little bit. And we've done a lot of work to pull together quite an extensive data set, and I've only really scratched the surface of some of the interesting findings that pop out from our ability to analyse this data in more detail for the UK. But I'm just going to illustrate one example here. So this is the profile, the tropical deforestation linked footprint of UK coffee consumption, and we can see that that's increased quite markedly from around 600 hectares per year in 2010 up to 1,400 hectares in 2017. So what's happening here? So something is going on. We can use our data to analyse the overall coffee consumption footprint of the UK, and we can see actually that's remained relatively stable. I mean, it's jumped around a bit, but it's remained relatively stable over the period at about 180,000 tonnes of coffee consumed by the UK per year. So the increase in deforestation is not just explained by an increase in the mass consumed, but if we break down that a little bit further, and again return to this tropical deforestation perspective, we can see that it's actually just this one region of production, Honduran coffee in particular, that's really leaping out at us as having really rapidly increased in its deforestation association to deforestation in recent years. So what's going on in Honduras? Well, again, we can look at the mass of coffee consumed from Honduras, which is coming into the UK, and we can see that actually, yes, that has increased again quite markedly. It's gone up from about 5,000 tonnes per year up to about just over 15,000 tonnes. So there is an increase going on there. But again, it's been quite high in the past, and maybe not as, that's not necessarily been associated with that increase in deforestation that we've seen. So let's have a look at some of the other data that underpins this. And in particular, we might want to understand whether this increase in consumption as well is driven by a more direct trade relationship with the UK, or whether that's happened because of some other trade patterns that have changed, which are sort of leading to embedded consumption of coffee in our supply chains. And we can see on the left-hand side from FAO stats, this is the direct export of Honduran coffee from Honduras to the UK. And we can see, again, that's increased rather markedly over the period. But in particular, on the right-hand side is this raw deforestation data that we're using embedded within the indicator itself. And we can see this really strong uptick in the deforestation linked to that production system. So we can start to see there how this data might be useful and how we can start to use pieces of the data set itself to unpick how the dynamics of land use change, deforestation and other environmental impacts might influence the UK footprint. There would, of course, be, off the back of this sort of analysis, further investigative work to be done in terms of looking at the production context, identifying whether that really is a risk that is reflected in the data, but is that a present risk? Having looked at the information that exists on from others, it does appear to be a problem. But we need to identify whether the UK was sourcing more sustainably via certification or via specific sourcing patterns that were avoiding deforestation, to make a real assessment on that specific product of whether we're linked to deforestation or not. But you can see how this sort of analysis might give us a rapid overview of some of the key hotspots overall. So I'll leave it there. Thank you very much, and hand back to Maddie.
So I've popped some links into the chat, so hopefully you can all go away and have a bit of a play, and maybe they'll stimulate some questions. I can see the Jamboard's looking a bit empty at the moment. But just to finish off, just a couple of quick slides on what's next. So Simon's already touched on this from a kind of methodological perspective. As he said, adding more commodities, in particular metals and mining, came up as a key priority with stakeholders, with the rise of electronics and rare metals being used there. We're quite cognizant that the current indicator is very focused on new production systems, whereas a lot of what we consume from the UK comes from older production systems, which might have different impact types, such as nitrogen and phosphorus pollution, improving the resolution of data. There's lots of things from the technical side. In terms of more immediate next steps, we're also really keen to get the word out and make sure that the people influencing action know about the indicator and how it could help them. So we're trying to get agenda space in various international meetings through DEFRA, do various comms activities such as this science talk, and we have a network of stakeholders across government, industry and NGOs who've expressed interest in using it. But I'd just like to take this opportunity to say, please do forward on the links to anyone you think might find them interesting. And we're more than happy to chat to anyone in a bit more detail if you think you might be able to make use of this indicator in your work at all. So just before we go on to questions, I'd like to take the chance to also highlight that we're also really interested in any feedback you have on either the indicator or the dashboard, both from a utility perspective. Do you think this is something that's important to measure? Do you see use cases in your own work? So we can identify, understand key audiences and provide evidence for its usefulness to support potential future work. But also from an improvements perspective, do you spot anything that you think would make it easier to understand, make the data more interesting, make analysis easier? So again, these contact points are in that little list I just put in the chat. And I'll just finish by saying that we're really excited that the data's finally out in the public domain, and we're really looking forward to people using it and hopefully making a difference. So with that, I'll hand back to Nikki.
Maddie, Chris and Simon, that was absolutely fantastic, really interesting to kind of see all the work you've done and this really interesting approach into something that's obviously quite dark corners of consumerism and supply chains. I can only imagine how tricky it has been, but it's incredible what you've done. And the dashboard looks fantastic. So for everybody here, we'll circulate those links to those resources with the recording of this talk as well, so anybody who's missed it can see it, and you can have a chance to look at those as well. But we've got a number of questions come in. So first, I'll go in through the chat. First one is from Ian. Do you use the GTAP database for any of your OI data?
No, not currently. So we use GTAP is what we used to use all the time, and then actually in this work it's the first time we used Exiobase, and the main reason for that change was one, in an attempt to have some alignment with the UK CO2 emissions calculations, but also because of the temporal coverage. But GTAP has much better regional resolution than Exiobase, and there's nothing to stop us basically plugging that back in and using it as well. So what we're keen to do is, one, incorporate that to get a second set of results, but also going forward maybe try and do something a bit more adventurous with some sort of interpolation between the two to try and get the increased geographic resolution along with the increased time series. That's been on Chris and my to-do list for a few years, but we'll get there. Right.
Thank you very much. Next question. Do you, or as you deforest, subsequently produce output of land cleared, so the need for deforestation decreases, otherwise all consumption coming from land at the frontier?
I'll take that one, I think.
Thanks.
So yeah, this is actually a really good question, and it's not one that there's a hugely straightforward answer to in many ways, because there's a very interesting conceptual and subjective debate, I think, going on about how, over what time period post the clearance event might you still be associated with that clearance event, you know, from a responsibility perspective. So one thing we didn't have time to cover today was the sort of details of the deforestation data set, but that actually uses a 5-year allocation period, and it annualizes the deforestation as well over that 5-year period. So essentially you can have a deforestation event of 100 hectares, and then that production will be split for the following 5 years at 20 hectares per year, and then linked up to the material coming from that. On the one hand, that's very good, because it obviously then allows you to say, okay, well, actually, you know, it's not just all this happening, you know, yesterday that's now linked, and then suddenly you're going to be free from deforestation because you're sourcing from there 3 years later. On the other hand, it does actually downplay almost the total impact associated with the production system. So in our data, this is an annualized measure. Actually, if you go back to the original deforestation, you'd actually come out with probably a higher footprint overall. So there's these trade-offs that we have to grapple with. But you know, we do see that if you change that horizon from 10 years to 20 years, for example, you'd have you know, a different, obviously, footprint overall, but also different regions of concern. You know, we've seen shift, for example, from Brazilian soy coming from the Amazon to the Cerrado habitat, which will explain the decreases in the deforestation rate that I'd shown earlier, in part.
Lovely, thank you. So another question from Jamie. Thank you for the presentation. And just to clarify, would the impact of soybean growth to feed cattle or for beef show up in deforestation stats for beef, soybeans, or both?
So that will show up under soybeans. So it's still very much linked to the raw commodity. One thing that the MRIOs allow you to do, and we haven't done, and we didn't discuss because we only had 12 minutes, is that you can look at the sector of purchase. So basically what you can do from the data we've got, the underlying data, is that impact will be associated with soybean, but you can look at purchase from which sector are in which purchases from which sector is that soybean production embedded. So what you would see is that, like, you know, we don't buy much soybean. We don't buy from the soybean sector. What we're buying is poultry, pig, to a lesser degree, beef and dairy, and that's where you would see that. So it is classed under soy rather than under beef. It's not embedded in the beef metric as such, but we do have ways to unpick that further, which we might explore in future.
Great, thank you. So moving over to the Jamboard, one question is there any potential to expand the indicator methodologies for fisheries and agriculture? This might align with the UK Fisheries Act ambition and on sustainable seafood supply chains.
So I'm laughing here because I'm just putting Simon through a world of pain as we try to do this for the Swedish data set that we're working on at the moment. And I also like the fact that this comment seems to be associated with an anonymous dolphin, so it's very apt on Jamboard. Yes, the short answer is actually yes, there is quite a lot of potential to do this. So FAO also collects data in something called FishStat, which is a very comprehensive data set associated with capture and aquacultural fisheries. We've actually already linked that up to Exiobase directly, not via a hybrid system, for the purposes of this Swedish project I mentioned. What we're also looking at is whether we can then extend that with information about the capture methods and also the discard rates associated with those capture methods to get more insight into the sort of associated impacts associated with those fisheries. There are some challenges because of the fact that, for example, the trade data for the fisheries is nowhere near as consistent as it is for the crop data. So that's going to be something we'll have to work on to do something like hybridized within the UK indicator set, but there's definitely potential to do that.
Lovely, thank you.
And we've
Maddie.
also got Yolanda from the marine team doing a bit of scoping on that this year as well. So yeah, in the forward plan.
Great, that's really exciting. Are there any countries that are missing data? That you're missing data from, sorry.
Yes, so and this kind of links to two. So first of all, there will be little gaps here and there throughout the data set that's kind of a bit impossible for us to really point to because we've got 160 commodities and 200 countries. But when I mentioned about kind of the trade data being messy, this is a prime example. So an example that came to light actually looking at the initial set of results was we got these quite high results for Myanmar with a certain commodity. And when we looked into this, just to sense check it, Myanmar itself doesn't report any trade data. So if you use, for example, the export records, basically there'll be no listing for Myanmar exporting to anywhere. And this is an example where we could potentially circumvent that by combining with the other data sets. So rather than have where there's a gap for exports from Myanmar, there will be import records from other countries from Myanmar, which you could use to supplant that. So that would be like how we could do this reconciled approach. It's also a bit of a perfect storm in terms of like the MRIO aggregation. So Myanmar also happens to fall within a rest of world region with 60 countries. So basically, Myanmar not being in the trade data doesn't mean that in any way Myanmar's production and trade isn't being captured. It's just not being captured explicitly within the physical component of the hybridized approach. But then also, it in terms of it all being handled by the MRIO, it's been handled in a very low resolution part of the MRIO. So everything is captured. There's nothing missing in that respect, but it's unfortunately not going to be anywhere near as accurate as the reports for some of the other countries.
Okay, thank you. Next question. Are there any plans to share this data more widely so that individual consumers can make informed decisions about what they buy?
I think so like I said, we're now in a phase of trying to get the indicator out there and used by as many people as possible. If anyone has any suggestions for contacts and kind of around getting stuff out to consumers, we'd be very interested in ideas. We've got in the stakeholder group I mentioned some of the industry people. So from the kind of industry perspective rather than like an individual consumer. But yeah, it's all in the public domain. So theoretically people can access it. So yeah, we now want to have a kind of push to get more people to know about it, but open to suggestions, no specific plan for targeting consumers directly at this stage.
I just to add, I think firstly, the dashboard is openly available to anybody, so it can be used by anyone who's interested in the data, which is the first time really this has been possible from the SEI data at least. I have been embarking on a little bit of a Twitter campaign linked to International Food Days, when there's like week of after our launch was International Fig Week or something ridiculous. So I tweeted a few things out on that. So I think there's plenty of opportunity, and I really do think this data can be quite helpful in raising awareness, particularly on some of those key commodities. But obviously it's, underpinnings are quite complex. So the trick is how you do that in a way that actually is understandable and also meaningful for people.
Yeah, I guess so far most of our efforts have gone towards the kind of policy side and getting matched up with the right people within DEFRA and other parts of government. But yeah, there's lots of other places it could be useful too.
Just quick on that, as well as the dashboard, all of the data is like publicly available to download, but it's not necessarily that accessible in that it's a big data set. You can't open it in Excel or something, so it's arguably not that democratized in some ways. But one thing we have discussed a bit is working out ways that we can do some almost like pre-prepared some scripts and stuff to do some mini info briefs or something, in ways to kind of make the data a bit more digestible. So once we can start breaking that down for certain commodities or certain countries, that'll be something that will then be able to be disseminated and perhaps be a bit more interpretable by a broader audience, I think.
That sounds good. Have you compared UK trends with other countries?
Go, Chris.
I was going to just dedicate to you, but anyway,
Okay.
a little bit is the answer, not extensively at this stage. We've been very tied up in just getting the data out, I think. You do see similar patterns, I think, with several European countries as the profiles have changed in similar ways. Likewise, you do see some of the emerging economies really ramping up in terms of their footprints associated with deforestation. So China and India, for example, with those increasing consumption footprints overall, obviously then linked to increasing environmental footprints. So there are definitely, clear trends that align with, macroeconomics, if you like. We haven't dug into the specific differences, I think, which is almost a more interesting question. So how does the UK footprint compare with the German footprint, and how might we align priorities around that as yet? But we do plan. Again, we've got another project actually at the moment with GIZ in Germany, where they're interested in their own footprints associated with deforestation. So the plan is to dig into a little bit of that for Germany, and there's no reason why we couldn't do something similar in due course for the UK data, of course.
We also have one of the visualizations on the dashboard is a ranking visualization, so you can see where the UK ranks compared to other countries assessed, and which countries are a few either side of the UK in that ranking. And again, we haven't done yet, but one of the possible use cases I mentioned was kind of evidence for multilateral environmental agreements. So things like the Amsterdam Declaration, their Fair Water Footprint Declaration. So matching up the UK and other signatory nations compared to others could be another potential future direction in that area as well.
Lovely, thank you. Next question. To what extent is the project advising on the state of the data for its purpose, for specific purpose and the use, and has the team made recommendations on the data and systems to improve how this trade data can be purposed for this type?
There's quite a lot in the question ultimately. I think so we do have very good relationships with lots of the original data providers. So for example, we collaborate with the Exit-based team. We also collaborate quite a lot with the group in Chalmers that I mentioned, who created the deforestation indicator, and we're in discussion with them as well about how we might extend that deforestation indicator into things like biodiversity to make them internally consistent there. Trickier, I think, is the actual trade information and the economy sectoral information, harmonizing that. So there's actually, in Europe, there's quite a good system within Eurostat of national accounting. So the Axiobase data set is largely consistent with that and therefore quite robust. In other countries, it's nowhere near as advanced. So you're dealing with sketchier data. I know the OECD are trying to provide some harmonized accounts via MRIO as well, which should improve things, but again, probably only if the OECD countries. And also we've got issues around, as Simon was mentioning, those problems with the trade data not matching up, and that I'm not sure will ever be resolved for various reasons. It's not just because people are reporting errors, but things can move from be misreported, but also they can move in destination for post-export, and also there are different standards around how you report destination and origin that exist for other reasons in terms of the trade statistics. So I think we do deal with this rather messy landscape. What I think this comes down to, probably in terms of what we can do, is to integrate alternative assumptions or alternative data sets so that we can sense check the results from one data set with another and undertake sensitivity analysis on those results.
Lovely, thank you. Next question. What is the rate of the update for this data? Over a 5-year period, the data shows marked changes, but the most recent data, 2017, is almost that long ago that there is a risk that the data could become out of date.
Simon, you want to take this one?
Yeah, so the 2017 sort of limit in the current release was largely guided by that being the most recently available year in the deforestation statistics, and as that was kind of one of the core parts of this, we basically took that as our limit. Different parts of the data have very different turnaround times and lags. The MRIOs can notoriously take quite a long time, and GTAP, the latest release of that came out, which I know we don't use in this work, but that was the most recent release of that was a couple of years ago, and that the most recent year in that is 2014, for example, which is one of the prime reasons we use Exiobase. Exiobase actually currently is available into the future because the most recent years are not based basically on fully unreported data, and so there's actually like projections available already. The production and trade data is typically available with fairly minimal lag, certainly available up to 2019, possibly even 2020 now. So it's almost a bit of a question here about, I mean, first of all, yeah, we're very much limited by what's available, but it's also then, do we start making decisions about having gaps in the data sets versus having consistency? And from a communication perspective, having things on the dashboard, that becomes problematic. So there's quite a few things to kind of consider here. There's no formal plans in place when it comes to the updates to this, but I think everyone involved is quite keen to make sure that that happens. And certainly from our end at SEI, this is something that we'll kind of look to be doing anyway, because we use this data in all sorts of other areas of work. I believe the deforestation data is now available for 2018, so in theory we could roll out 2018 for this. But also with some of the methods for some of the indicators, we've basically had to use varying degrees of like extrapolation and interpolation. And again, it's sort of a bit of a balancing act of like, where are we getting into risky territory of like taking things a bit too far for the sake of filling gaps, basically. So I don't know if that really answers the question, as opposed to just makes it more complicated, but that's sort of my best attempt at that.
Lovely, thank you. And is there any plans to repeat the process, like in specific time cycles or anything?
So we're hoping to be able to do annual updates, funding dependent, as part of the UKBI on the same timeframes as the UKBI updates, because it's one of the UK biodiversity indicators.
Perfect, thank you. I'm afraid we're actually out of time, but there are quite a few other questions in the Jamboard. So what we can do, I'll email these to the presenters today, and we'll get some answers and circulate these again with the recordings and the links. If you guys are happy with that.
Yeah, I think we've been adding answers on some notes as well. So.
Oh, lovely. Okay, brilliant.